All right, so 8.5, we're looking at all the different properties of logarithms. We are looking at how to combine logarithms and also expand logarithms. Doing this allows us to solve these logarithms a little bit easier. Sometimes it's easier if you expand them, other times it's easier if you combine them. So there are 3 rules you need to know for these logarithms. First one is if you have 2 values like m and n, and they're being multiplied, you can separate them into 2 separate logarithms with an addition in between the 2. If you are dividing 2 things, you can separate them with a subtraction. And lastly, anytime you have an exponent like k that's on a logarithm, you can pull that down in front of the logarithm. So these 3 ideas right here we're going to put together in probably multiple steps. Within these problems, we're going to just practice expanding and combining, okay, with these 3 rules. They're the only 3 rules, okay, and they only work when there are common base numbers, okay, meaning right here. So all of them, notice, have b's on every single one. So you can't combine 2 logarithms if they have different numbers right there. All right, so we're going to look at these 3 rules. And first we're going to combine. So these are going to be all separate and we want to put them together into one logarithm. So starting on the first one, we've got log base 3 of 20 minus log base 3 of 4. Now, remember from the first slide, if 2 logs are separated by a subtraction, that means when we put them together, we're going to divide the 2 items. So when we put these together, we've got log base 3 of 20 over 4. Now this can be simplified, so this would be better to be written like log base 3 of 5. So that would be the answer for that one, combining those 2 logs. All right, the next one. Remember that any number in front was really up as an exponent on that variable or number. So let's take this in 2 steps. This will now look like log base 2 of x cubed plus log base 2 of y. Now if there's a plus separating the 2 logs, when you put them together, remember we multiply our 2 items, this item and this item. So now we have log base 2 of x cubed y. The next one, we have a subtraction, so again we're dividing the 2 things. So I'm going to skip to the very end step. Okay, 9 over 3 would be log base 2, 3. And then we've got a couple multiple step ones. All right, this one has a number out front, so it's really up there, so 2 cubed. So I'm going to just rewrite this as log 8. And I didn't change anything else. So remember, addition means you're multiplying the 2 things when you put them together, and subtraction means you divide. So really this looks like this. Log 8 times 4 over 16, which simplifies to be log 2. All right, this one has a number here. Okay, we're not moving the negative 2 up. The negative just means we're subtracting 2 things. So I'm going to rewrite this log 8 minus log, and 2 squared is 4. So again, subtraction means we are dividing. So we could take it in steps. The last one I put them all together into one, but we can take this in steps as well. So we start from left to right. If we combine these two, we're dividing the 8 and the 4, so this is really log 2, and then we have plus log 3 here. And if we combine those, we multiply, so we have log 6. So that's examples of combining logarithms. Now we're going to go the opposite direction. Okay, they're going to be together into one logarithm, and we're going to break them up into multiple logs. So we'll start here. Remember, if you're dividing, that means we separate our logs with a subtraction. So we've got log base 5 of x minus log base 5 of y. And that's it. That's expanded. The next one. There are two things here. We have 3 and we have r to the 4th. So I'm going to split those up. Log 3, if they're being multiplied, remember it's addition. And now this is log r to the 4th. We have one more thing to make it completely expanded, is to move that 4. So remember, exponents on logarithms can always move down in the front. So we've got log 3 plus 4 log r. So these are the expanded versions. Log base 2 of 7b. We've got two things. So we've got two logs when we expand it. We're going to be adding in between. And nothing else to simplify there. Now notice on the second one that we did, the exponent was only on the r. So the 4 was only in front of that log with the r on it. This one right here, the next one we're going to do, everything is squared. So both logarithms are going to have a 2 in front of them because the y is squared and the 3 is squared with those parentheses. So this is going to be 2 log y 2 log 3, plus or minus. Will be minus. So 2 log y minus 2 log 3. That's your expanded form. And one more, practice. So notice the exponents on these. The a is cubed and the b is to the 4th power. So when we split these up, I know there's going to be a plus in between them. On the first one, we've got 3 log base 7a, and this one has a 4 log base 7b. So there's some practice on expanding and combining logarithms using the 3 rules, 3 properties of logarithms. That's going to come really handy when we're looking at the assignment in the next couple days, next couple sections. So we've got one slide left. Okay, so you're going to have problems that look like this. So on this first one, it would help if we could combine what's on the left-hand side so that we just have one logarithm. So let's do that. We've got log base 3. If there's a subtraction, that means we're really dividing these two things. Now, when we have equal logarithms, if we have log base 3 and log base 3, the things that we are taking the logarithm of should also be equal. So what we can do here is say 56 over n is equal to 7. So if the two logs are equal, those two items that I put blue rectangles around should also be equal. So in this algebra problem, we would want to multiply both sides by n. So we've got 56 equals 7n, divide by 7, n equals 8. Now we do need to check these because they're not always going to end up being true. But if we put this 8 value in for n into our original, we're going to get log base 3 of 7 equals log base 3 of 7. So we're good. Those do have to be equal. Okay, so that would be your answer for that one. N equals 8. Let's try another one. On this one, we're going to want to move this so that it looks like the combined form of x to the 5th, log base 2 of 32. Notice we have log 2 and log 2, so these also have to be equal. Some of you can do this in your head and know what the value of x is, but in case you don't, we can raise both sides to the 1/5 power. We did this before, so the 5 and the 1/5 right here just become x to the 1st power, and 32, if you put that in your calculator, to the 1/5 power is 2. Okay, putting the 2 back into the original, if we put that right there, you're going to get 32, and log base 2 of 32 is equal to log base 2 of 32. So this one works. And we have one last one. So on the left, we have two logs. We're going to want to put those together. So we're going to be multiplying the a and the a plus 21. So if we do that, that'll be a squared plus 21a equals 2. Now this is a little bit different than the other two problems that we just did up above. Okay, we don't have a log on both sides, so we can't just set those things equal to each other. But what we can do is change it to exponent form. Okay, right now this is in log form, and when there's no number, remember there's really a 10 there. So we can change this to exponent form. Remember, exponent form takes this number, raised to this number, and sets it equal to whatever is here. So we have 10 to the 2nd equals a squared plus 21a. Well, this is 100. Still, right here we need to figure out solutions. Because we have an a squared, it means we're going to have two numbers for solutions. We're going to have to factor this. So in order to do that, we do need to move everything to one side. So we've got a squared plus 21a minus 100. And now we're going to want to factor this. So we draw an x. Some of you learned how to factor a different way. It's totally fine. This is how I organize my thoughts here. We need a number that multiplies to be negative 100 and adds together to be 21. So it needs to multiply to be this and add together to be this. Hopefully you've thought of 25 and 4 and putting a negative on the 4. So those are the two numbers that we put with these in our parentheses. Now we set both quantities equal to 0. Remember doing all of this. This is a review, nothing new. If we set this one equal to 0, we get a equals negative 25, And here we get a equals 4. Now up at the top it said we need to check our solutions. I'm guessing one of these is not going to work when we put this back in. Okay, so let's look at the original here. We've got log of -25 plus log of -4 equals 2. Okay, we also have to check the other one, which is log 4 plus log 25 has to equal 2. Okay, taking a log of a negative number is not possible, so we do have to throw this one out and just use a equals 4. So that's everything in 8-5.